So anyway, divide polynomials using long division. Let's practice this. Mateo, you were saying something here. 16 doesn't go into 3, right? 16 doesn't go into 3, does it? Close. Really close. Not 56, it's these two here. The 35. How many times does 16 go into 35? How do we know it's twice? Exactly. 16 times 2 is 32. You can't go any higher than 35. If you put a 3 here, then that means that this is 48, and you can't take 48 from 35, can you? So it doesn't go in 3 times, it goes in twice. 2 times 16 is 32. Now what? So the phrase I like to use, not so much with numbers, but especially with polynomials, is draw the line and change the sign. Say it. You need to remember that. Draw the line, change the sign. All right, 32 from 35 is 3. Now, does 16 go into 3? You got to bring down the 6, exactly. Bring down the 6. All right, here we go. 16 into 36 is another 2. And 32, let's see, 16 times 2 is 32. What's the phrase? Draw the line, change the sign. 32 from 36 is 4. Now, this is pretty important that you understand what happens here. That does eventually turn into a decimal point. Question that you answer yes or no. Does 16 divide 356 evenly? How do we know that? There's a remainder of 4. What if this happened to be 0? It's not 0, but what if it were 0? What does that mean? Divides evenly. That means that this number is a factor of that number, if it divides evenly. But it doesn't divide evenly, so we have a remainder. Now, depending on how much you remember from elementary school, initially you probably wrote it like this. 356 divided by 16 equals 22, remainder 4. Remember that? Okay, but as you got a little more sophisticated with math, well, that was even more sophisticated. You started doing decimal points. You remember what to do with that remainder other than using R4?
Oh, you put 4 over 16.
Exactly. You add the remainder over the divisor. And that's your answer, 22 plus 4/16. Or 4/16 is really 1/4.
So the way that you would interpret this is 22 goes into 356 how many times evenly? It goes in 22 times evenly. And if there's a remainder of 4, that means there's a quarter of 16 left over because there's a remainder. Does that make sense? That's where this quarter comes in, 4 over 16. If the remainder is 4, it goes in a quarter more times, which is 1/4.
So this transfers over directly to how we divide two polynomials using long division. It's going to seem strange, but it's the same exact algorithm as this. So let's take a look at polynomials. You ready? So here's the problem we're going to look at. X squared plus 8x minus 4 divided by x plus 3. Because in our first lesson, we already learned how to add two polynomials together. How do you do that, by the way? Let's just review real quick. How do you add two polynomials?
By combining like terms, right? You're scaring me a little bit. How do you subtract two polynomials? Subtracting like terms. How do you multiply when the polynomials are parentheses like that? How do you multiply them together? Distributing, or the FOIL method, right? So we've done add, subtract, multiply. It would make sense that eventually we're going to divide, right? So that's what we're doing now. We're doing divide.
So first step is to set up the division problem using that division bar. What goes inside? What goes outside? X plus 3 goes on the outside, exactly. X plus 3 is dividing x squared plus 8x minus 4. So you have to set it up like that. Okay. So So now you gotta watch and listen very, very carefully. When you're doing this polynomial long division, you only consider first term compared to first term. Okay? Does x divide into x squared? So the question is how many times though? How many times can x go into x squared? So maybe an easier way for you guys to think about this, I've got to put a number or a term, not a number but a term up here, so that when I multiply this question mark by x, I match x squared exactly. I want to match x squared exactly. So what do I have to put right here to multiply by x to get x squared? Another x, right? And there's a reason that I want to match x squared exactly, and I'll tell you that in just a second. But I want you to understand where did this x come from? How did I know it's going to be an x here? Because it multiplies this x, what am I going to get? X squared exactly. And it's important that these two terms match up exactly the same. Okay? Because here's why. X times x is x squared. What's x times 3? So I'm going to put a plus 3x here. What was that phrase I used a little while ago? Draw the line. That applies to all the terms here. Change the sign of all the terms. Draw the line, change the sign. Do you see why it was so important now that these terms matched up exactly? What happens now? They cancel each other out. And that's why this process eventually ends. If you didn't cross out this x squared term and you ended up with another x squared term, this process would just go on forever. But because you crossed out the x squared term, now we're just dividing into 5x, you drop down to minus 4, so now we're just dividing into 5x minus 4. The process starts over now. And again, it's only first term here compared to the first term here. So how many times does x go into 5x? Or maybe easier is, what kind of a term could you put here so when you multiply it by x you get 5x exactly? Plus or minus? Plus 5, right? So I'm going to put a plus 5 up there because 5 times x is 5x. You want to match up those terms exactly. 5 times 3 is 15. Draw the line and change the signs or switch the signs. Those cancel and we get negative 19. Now that is our remainder, but you need to understand why. It's not necessarily the remainder because there's nothing more to drop down. That's not why it's the remainder. Okay? Are you guys listening carefully? This is the remainder because even if I tried to think of a number to put up here to multiply with that, am I ever going to match up with negative 19? No. That's why we're done now, because x can't go into negative 19. What's that? It's prime, yeah. So this is the solution here, x plus 5. So when this is divided by that, the answer is x plus 5, but we have a remainder. So how do we write the remainder? Plus negative 19 over x plus 3. And that is how you divide two polynomials using long division. Okay. So it's very similar to that process with numbers. You just have to be a little more careful. Not terrible, is it? Let's have you guys try one on your own. See if you can do that one all on your own. All by yourselves. Take the training wheels off. All right. Quit your arguing. Like an old married couple back there. So, x minus 2 divided into x squared plus 12x minus 3. So, in order to end up with an x squared right here, you've got to put a single x right there, yes? Because x times x is x squared. X times negative 2 is negative 2x. Draw the line and change all the signs. So that becomes a plus. Okay? X squared minus x squared cancels. 12x plus 2x is 14x, and then you have that minus 3 that drops down. The process continues now. Okay? In order to get a 14x right here, that multiplies with x there, what do I have to put here? Plus 14. 14 times x is 14x. 14 times negative 2 is negative 28. Draw the line and Change the sign, so those are gone. 28 minus 3 is 25. That is your remainder. Okay, this is your quotient right here. So the answer is x plus 14 plus 25 over x minus 2. Yeah. The 14, it multiplies the x here to get the 14x, but then the 14 has to multiply the negative 2 to get 20. Okay. Yes.
If it were to equal 27, then could you simplify it?
If what was 27?
It's like remainder 27.
If that were 27 right there?
Yeah, because then you would minus 2 and equal 25 and
Where?
I don't know.
So,
I don't even know what I mean. Sorry.
When do you ever change it? No, you not ever change it? Okay.
you never change the remainder. So the reason that we're done here, Colton, is even if I tried to put another term up here, like whatever it was, I couldn't multiply that by x and have it equal 25 exactly. Does that make sense? So 25, and if it is the remainder, you just leave it. You never change the remainder. So let's do question 1 on the lesson, or on the, not the lesson, the worksheet. Let's do this one together. I know I didn't give you a ton of room, I'm sorry. If you need to use your own paper, use your own paper. What I absolutely will not accept on this is if I just see answers and no work. There's no way you guys can do this in your head. Okay? You can staple it to this. So question 1. Woo, that's not question 1. Here we go. So we have 15m squared minus 4 Gesundheit. 44m minus 19 is divided by 3m minus 10. So it's the same process. It's a little different now because we have a few numbers in front, which makes it more fun. So what can I put up here to multiply with 3m? 5m. You guys follow? Where'd the 5 come from?
15 divided by 3.
Yeah, 5 times 3 would get you the 15 here, and then m times m gets you the m squared. That's why it had to be 5m right here. Okay, but you don't just multiply the 5m by 3m. The 5m also has to multiply the negative 10 to get negative 50m. The 5m multiplied both of these terms here.
Okay.
Now you draw the line. What's the phrase? Draw the line, switch the signs. So those two signs switch. Draw the line, switch the sign. If these first two terms don't cancel, that means you've done something wrong. Those terms always, always, always cancel. Now, what's 50m minus 44m? 6m, and then you drop down to 19 and start over again. It would just be 2, right? All we need is a 2. Because if you put a 2 right here, then 2 times 3m matches up with that 6m. It's really important that these first terms match up. And then 2 times negative 10 is negative 20. Draw the line, eh? Change the sign. The 6m's are gone. 20 minus 19 is 1. That is your remainder. Okay? So your answer is 5m plus 2, that's your quotient, plus the remainder of 1 over 3m minus 10. That's how you represent the answer. I think it's a little bit easier than our last lesson. Now, this is the 4th page of your test.
This would be pretty easy test. Something like quadratic, I always mess up with it. I always like to do some simple math or anything.
Okay. While we're at it, since we have a little bit of time here, let's do question 2 together as well. Yeah, we're learning more. This is not all today. So question 2, you got 4n to the 3rd minus 25n squared minus 61n minus 27. So this is a third degree polynomial. So, Gabby, what were you saying?
Would be n squared.
Yep. How come?
Because 4n and then 4 third is square root of
Exactly. That's good. Did you guys hear that? All I need right here is an n squared. Because n squared times 4n is going to get me that 4n to the third right here that I need. And then n squared times 3, n squared times 3, come on now, n squared times 3 is plus 3n squared. Draw the line. Change all the signs. So the 4n cubes are gone. The one thing that students just struggle a lot with is not being careful with this. Negative 25 and negative 3, what does that combine to? Negative 28. Negative 28 n squared. Now drop down all the other terms. We have a negative 61n minus 27. And our process starts over. So how many times does 4 go into negative 28, first of all? So we need a negative 7 up there. And then n into n squared. We need another n, don't we? So now if we multiply negative 7n with positive 4, we get negative 28n squared minus 21n. Draw the line, switch the signs. So the 28n squareds are gone. Oh man, let's see. Negative 61n plus 21n is negative 40n. And then you drop down that minus 27. Do you guys have a question? If you have a question, it's good. Ask a question, Peter. Yeah, 4n into negative 40n is a minus 10, right? Minus 10 times 4n is negative 40n, and then 10. This negative 10 times that positive 3. The 10 times negative 3 is negative 30. Draw the line, switch the signs. 40s are gone. 27, or negative 27 rather, plus 30 is 3. So that's your remainder. So to answer the question, this is your quotient up here. N squared minus 7n minus 10 plus the remainder of 3 over 4n plus 3. I know, I'm sorry, I didn't give you.
So question 3 is pretty straightforward. It's a lot like these two. There is a little bit of a problem on question 4. I want you guys to look really carefully. It's in the first polynomial. Brian sounds like he found it. Don't say anything yet. There is a big problem on question 4. In the first polynomial, do you see what I'm talking about? What's the degree of the polynomial in question 4? It's a third degree, right? That means there should really be 4 terms. If it's a third degree, there should be 4 terms. How many terms are there, though? There's only 3 terms. We're missing a term. That's a huge problem in this process right here. If you're missing terms, that messes things up.
So I'm going to help you set up the problem on question 4. You guys will have to finish it for homework. So, and just maybe so you don't forget, put a little star by question 4 and put missing term so that you can remind yourself that that is a big deal. So on question 4, you're going to have the 2r to the third plus 6r squared. And this is where that missing term should be, right? So you need to put a plus 0r. And then minus 8. All of the terms need to be represented, otherwise this process doesn't work. And what is 0r? It's nothing, right? What did I add to this polynomial? Nothing. All I put is a placeholder there so that the division will work. Okay, and then the rest of it's the same, 2r plus 6. So you guys ought to be able to finish it from there. Okay, so let's just review what we've done so far, you guys. Go back up to the top of your notes. The objectives were to divide using long division. We have done that, right? We need to move on to this second objective. You guys listen carefully. Synthetic division is way easier, it's way faster, and it gives you the exact same result as long division. It's called synthetic division. Okay? It's quicker, it's easier, I think it's more accurate, and it gives you the same result, so why not use it all the time? It doesn't work all the time. Unfortunately, it only works some of the time. But anyway, let's talk about it. Synthetic division, that's our next topic. So synthetic division would work on this problem. We've already did it. This was the very, very first problem we did. We're going to do it again using a different method, the synthetic division. But I want you to write this problem down and just stop, because you need to understand when it does work and when it doesn't work. Because if it does work, I would always, 100% of the time use synthetic division. It's quicker. So, you ready to listen? Here's when it does work. Okay, synthetic division. Actually, I want you to listen and write. Only works when the denominator, or whatever you're dividing by in this case, when the denominator is a first degree polynomial. All right, what does that mean? What does a first degree polynomial mean? It means it has to be an x to the first, right? Is this an x to the first?
Yes.
So this is a first degree polynomial, but that's not all. It's a first degree polynomial with a 1 in front, meaning a 1 in front of the x. So if it's a first degree polynomial with a 1 in front of the x, then you can use synthetic division. Okay? So looking at your worksheet, could we have used synthetic division on question 1 on your worksheet?
Yeah.
Why not? There's a 3. What about question 2? No. 3 or 4? No. But question 5, I mean, other than it says use synthetic division, if those directions weren't there, if you were just to look at that problem and you're deciding, hey, should I use long division or synthetic division, what would you decide on question 5? Synthetic. Definitely synthetic. It's way easier. Okay? It is a different process. Okay? It is much different. So here it is. It may take a little bit of time to get used to, but once you learn this, it is so quick. So it starts with an upside down division bar. So draw an upside down division bar. Okay? Now you need to leave room in this for like 2 columns. I'm going to draw a dotted line. I don't want you to draw anything, but there's really 2 rows right here. There's a row of numbers that's going to go here and a row of numbers right here. So you got to make sure that this division bar is big enough. Does that make sense? So in the top row, right here, you're going to place, I want you to write this down, you're going to place the coefficients of the numerator. Only coefficients. Synthetic division doesn't use any variables. It only uses numbers. So what are the coefficients in order of the numerator? What's the very first coefficient? 1. What's the next one? 8. And technically negative 4 isn't a coefficient, but we still use all the numbers. So you have 1, 8, and a negative 4. You okay so far? Now usually there's not a circle there, I just wanted to put it there so you knew where to put the numbers. I'm going to erase that. Now we also need a number right here in front. Yeah. That number is the 0 of the denominator. The 0 of the denominator. You understand what I mean by 0?
So it'd be -3. And that's one of the common mistakes I see students make, is this number that goes in front. It's not a +3, it's the 0 of the denominator, which in this case is -3. So put a -3 there.
Right, and here's the process. And again, we'll go slow on the first couple, but once you get this down, it's real quick. You always start by dropping that 1 down to the very bottom right here. Okay. Now, numbers on the outside always multiply. These two numbers are on the outside, so they multiply. -3 times 1 is? So I'm going to write that -3 right here underneath the 8. Where did -3 come from? -3 times 1. Now, if the numbers line up in a column, then you add 8 plus -3 is 5. But now look, these two numbers are on the outside, the -3 and the 5. So what happens? They multiply to be -15. And then these numbers are in a column, so they add to be -19. So now the process is over. Now we just have to interpret the result. This is always the remainder. Isn't that what we got as a... We've already done this problem as a very first problem. Did we get a remainder of 19 up there? Or -19? Okay. These numbers, these are the coefficients of your quotient. All the quotient is the result of the division. So if something's divided by something and it equals something, that's called a quotient. So your quotient isn't 1 and 5. These are the coefficients of the quotient. And if you work your way from right to left, this number is always just a single number with no variable. The next number after that is an x. If there was a number in front of that, what would that be? An x squared, and so on and so on. So if this is a 5 and that's a 1x, then what's the quotient? The quotient is x plus 5 with what remainder? So plus -19 over the divisor. What were we dividing by? Originally, what were we dividing by? X plus 3. So that's the answer. It's going to take a little bit getting used to, but when it works, it is significantly faster. So, let's do one more real quick as an example in your notes, and then I'll help you do some of the ones on your worksheet. So, here's another example. You're going to divide 2x squared minus 3x plus 8 divided by x plus 5. BJ.
Can you grade it for me? Yeah. Hey, thanks.
So upside down division symbol, what goes in the top row? Coefficients of the numerator. So tell me what to write. 2, -3, 8. That goes in the top row of the upside down fraction bar. And then on the outside, what'd you say, Brian? On the outside? -5, exactly, -5 on the outside. -5 because that's the 0 of the denominator. Bring down the 2. -5 times 2 is -10. Add straight down, right? Ooh, man, negative 60 or positive 65. What is that?
That's 65.
Negative 5 times negative 13 is positive 65. 65 plus 8 is 73. So the remainder is 73. You also have to interpret these two numbers. What do these two numbers mean?
2x.
The coefficient of the quotient, right? So what do they mean though? 2 and a negative 13? It's 2x minus 13 plus the remainder of 73 over x plus 5. Isn't that cool?
That's yeah. Okay.
Why is it 2x?
Whoa, we just erased it. Because there's a 2 right here. This is the coefficient of an x term, and this is just a normal number. So it's 2x minus 13. So let's do number 5. On the worksheet. So start with your upside down thing. Remember, synthetic division is only numbers, no variables. So what are we going to have? We're going to have a 1, negative 12, 27, and negative 17. And what goes in the front here? Positive 2, yeah? Positive 2. Give you like 20 seconds here. Go through the process, see what you end up with as a result.
Just doing problem 3.
You're doing problem 3?
I was doing problem 3.
Problem 3 doesn't work.
Yeah. Like wait.
Try if you can to go all the way to an answer. Alright, this is where I am, and I'm stuck. You guys are gonna have to help me out here. I've finished the synthetic division part. At least I think I have. Is that right? Is that what you're getting? But how do we interpret all these numbers on the bottom? Dang it! Which one's the remainder? Negative 3 is the remainder. So what do these other 3 numbers mean then? 1 is an x squared term. So that we have an x squared, and then the negative 10, what's that? That's a negative 10x. And then the 7 is just a 7. So your quotient is x squared minus 10x plus 7. And then you have plus the remainder of 3 over, or negative 3 over x minus 2. Okay, so question 6 is a lot like that one. You can do that for homework.
Do you notice a problem on 7? Take a look closely. 7. Problem, yes, no?
It's a squared, it's a second degree polynomial that should have 3 terms, right? There's only 2, so what's missing? Where is it missing? The term in the middle, so that also affects your synthetic division. So take a look. Placeholder. We're going to be having a negative 5 in front, but on the inside you have a 1 because you have a 1p squared. But what has to be in the middle? 0, because there's no p terms. You have to have a 0 there. And then at the end, negative 22. Just keep that in mind. Okay.
We okay so far? Okay.
I know it's been a lot. I wish we could just say we're done. We're not quite finished. Okay. So hang with me here for just a few more seconds. You'll have to do some of this stuff just as homework. Okay? I need your eyes up here at the screen. The next and last topic is just applications, mostly of synthetic division. Okay, here's a question I want you to write down real quick. Is x plus 2 a factor of x squared plus 7x plus 10?
Now, if I just left it up to you to come up with your own way to answer this, because there are a few different ways you could answer this, not using synthetic division, how could we know that x plus 2 really is a factor of x squared plus 7x plus 10? How do we know that? Or how could we know that? We could factor x squared plus 7x plus 10, right? If we factored x squared plus 7x plus 10, what would the two factors be, the two things in parentheses?
And just for sake of time, it sounds like I just better tell you. It would be x plus 5 times x plus 2. So is x plus 2 a factor? Yes. Okay, but that's not how you're going to do this assignment. Okay? We need to relate this to something you know regarding division. Here's an easy question. Is 4 a factor of 12? How do we know that? True, but relating this to division. I don't want you to relate it to multiplication, relate it to division. How do we know that 4 is a factor of 12?
With what remainder? No remainder is the key. You guys listening?
If you divide 12 by 4, do you get a remainder? 12 divided by 4 equals what? 3 with what remainder? That is the key right there. So check this out. If I took x squared plus 7x plus 10 and divided it by x plus 2 synthetically, that means it's going to have a 1, a 7, and a 10, right? And then what out here? Negative 2. Now watch. Drop down the 1, negative 2, multiply by 1. We get a 5 times negative 10. What did we get? Remainder of 0. What does that mean? It means there's no remainder, true, but what does that mean about x plus 2? It goes into it evenly, which means it is a factor. You guys follow? So the next set of homework questions starting on number 9. Take a look at number 9. It says state if the given polynomial is a factor of the bigger polynomial. So just for sake of time, let's do number 9 together. Number 9, essentially what they're asking is x plus 10 a factor, you don't have to write this down, but is x plus 10 a factor of 5x squared plus 49x minus 4? What's a really easy way of answering this question now? Doing synthetic division and hoping for what? What should we hope for? A remainder of 0. If we do get a remainder of 0, then what's the answer to the question? Yes. If we get a remainder other than 0, what's the answer? No. So these really aren't that long. If we do the synthetic division, we're going to have a 5, a 49, and a negative 4, yes? What goes in front? Negative 10. Bring down the 5. Negative 10 times 5 is negative 50. That makes negative 1. That makes a positive 10, and we get a remainder of 6. So all of these questions, 9 through 14, are either yes or no answers. What's the answer to number 9? No. The answer is no, because we didn't get a remainder. You follow how that works? Okay. We're still not done, you guys. I'm sorry. There's one more application of synthetic division. Yes, and this is also pretty easy. Write this down in your notes real quick. If I gave you this function, f of x equals 3x to the 4th minus 2x squared plus 3x minus 10, and I asked you to find this, don't do it yet, because I know most of you probably know what to do, but
I just want you to explain to me what. If I asked you to find f of 4, how would you do that? Remember this from last year? You plug a 4 into all the x's, and then you just do all the math and see what it equals, right? This is what you learned hopefully last year. You'll see a couple of blank stares. If you don't happen to remember, does that make sense though? If I asked you to find f of 4, you would plug the 4 into all of those? Okay.
Let me show you what that would be just real quick. This would be 3 times 4 to the 4th power minus 2 times 4 squared plus 3 times 4 minus 10. Is that very easy to do in your head or by hand? Help me out real quick, calculator people. What's 4 to the 4th power? Quick, quick, quick. Okay, then 256 times 3. Come on, we got to hustle. So we have 768 minus 4 squared is 16 times 2, so that's minus 32. Plus, now we have 3 times 4, that's 12. Then we have a minus 10. So somebody do that for me real quick. 768 minus 32 plus 12 minus 10. Is that what it is called? 738. Now, what does this have to do with synthetic division? Check it out. If I take the original polynomial here, 3, negative 2, 3, and negative 10, and then I'm going to take that number that we're applying and put it here. You guys watching? Drop down the 3, what do we get? 12 and a negative 2 makes 10. 4 times 10 is 40. 4 times 3, or 4 plus 3 rather, sorry. 43. 43 times 4. Come on now. Alright, we've goofed up on this thing. Oh, you know what we did? I'm an idiot. What's missing here? I completely overlooked that. Alright, we need a 0 right here, don't we?
Yeah.
And then we need a negative 2 and a 3 and a negative 10. Okay, the bell's going to ring in about 30 seconds. I just want you to hang tight for just a little bit. Let's start again. Drop down the 3. 12. 12 plus 0. 12 times 4. 48 minus 2. 4 times 46. Come on now. Calculator people. Come on, y'all got them. What is it? 184 plus 3. 187 times 4. Don't leave yet. 748. What's 748 minus 10? Okay. You guys see what happened here?
So on your worksheet, the last section says evaluate the function. It doesn't mean to plug the number into the function. What does it mean to do? Use synthetic division, because the remainder is going to be the same thing had you done the substitution. Okay?
Sir, sir, मैं comment की office agent के रहना